Hi everyone, my name is Sylvia Azumah, and I am a second year master's student at the School of Information Technology here at University of Cincinnati. My research proposal is entitled Deep Learning Based Anomaly Detection System for Garden IoT Devices. So to begin with the abstract, we know that there has been a technological advancement of using IoT devices in our world today, and these devices has become somehow important to us humans. And as it's become beneficial to us, the security issues that are associated with these devices are also rising day in and day out. But mostly, since we don't know about it, they are actually left unattended. So according to research, it shows that 70% of IoT devices are easy to hack. I mean, that means that a lot of our information is being transferred or transmitted without we even knowing about it. Therefore, I was like, therefore I thought it wise to think of a mechanism that can be put in place to safeguard these devices that we use. And so I proposed that an LSTM deep-based anomaly detection model is used to predict or to classify cyber attacks in IoT devices. So upon hearing IoT, now we want to know what IoT means. IoT simply means Internet of Things, right? And these devices nowadays have become very, very helpful to us as humans, because I mean, we've gotten to a point where people don't want to put in the effort to do certain things anymore, and they feel like something else or a gadget or a device should be able to do that for them. Just like people have their iPhones and they are so confident to say, hey Siri, can you turn off the music for me? Hey Siri, can you dial this number for me? It's the same way IoT devices have become so important and beneficial to us as humans. But even though they are beneficial to us, our data receives and transmits data daily when it's connected to the internet, and that is why we have to be conscious of what we have. I mean, and what to know what is being transmitted out there. But then some people they might say that, oh, I don't have the time to know what is being transmitted out there. That is where the anomaly based detection system comes in here, because I mean, we can't always be sitting around and say that, oh, we want to know what is happening to our device. I mean, we want to know which data is being transmitted and all that. We don't have the time in the world to do that. And so there's a need for us to put a mechanism in place that is going to help us detect what is going on in our IoT devices. And so we decided to propose a deep learning based anomaly detection that would safeguard these IoT devices. Moving on, IoT devices, are subject to different forms of attacks. Say denial of service attacks, man in the middle attacks. Just as a normal network is vulnerable to attacks, same way IoT devices are also vulnerable to attacks. And we can see, I mean, IoT devices are used in various places, such as the hospitals, in our offices, in transportations, in homes, in agriculture, energy, in our smartwatches, and even in our smartphones, our cars, and everywhere. And also, this IoT attacks fall under the categories of privacy, authentication, integrity, and confidentiality. If you are really good in, or if you know the field of cybersecurity, you know how important the CIA traits are when it comes to cybersecurity, which is confidentiality, integrity, and authorization. And so it is very, very necessary that these devices are safeguarded. Moving forward, the Internet of Things architecture can be classified into 3 layers, which is the physical layer, the network layer, and then the application layer. The diagram in figure 1 shows a clear view of how the IoT device architecture is, representing some of the devices that are used in those various layers. Those various layers also have some specific attacks that occurs there, right? So moving on to the main aim of this proposal, of this research. So this research is proposed to focus on detecting anomaly detections in IoT devices. As mentioned earlier, our devices, when connected to the internet, transmit data out there that we are unaware of, and they need to implement a mechanism, an extremely good mechanism that is going to help to protect our devices, even though they transmit data out there. This anomaly detection should be able to block certain things when unauthorized users try to access them. Yeah. So with the proposed model, there's a solution of using a long short-term memory model that is going to detect, or to classify these attacks, and to tell the user when something is wrong with their IoT devices or something is occurring on their network. Yeah. So to get this done, we came up with a proposed method, and the proposed method that will be used, as mentioned earlier, is the LSTM model. But then also we need to know what entails in this whole process. So the first process that we are going to be considering will be our data set. So this data set, which is called the IoT intrusion data set, and it contains a whole lot of features in there that can help these deep learning anomaly based model to detect both anomaly and normal on IoT devices. So this data set comes with a lot of features. Some of the features include source IP, destination IPs, labels, categories, destination packets, like names of packets, attack kinds, and all that. But to be specific, or to make our output very clear to the user, I decided to use just 4 features of the data set, which I think would be very beneficial. So one of it is the source IP, and then we have the destination IP address. We have the labels, which contains both the normal data and abnormal data, and we have the attack category, which gives a breakdown of the type of attack that is occurring on the network. So after the data set, the next thing that we would like to have is our experiment setup. And to have the experimental setup, you're going to be using Windows 10 operating system with an Intel i5 core processor with 256 SSD, 1 terabyte hard drive, a 16 gig RAM, and an NVIDIA GTX. Also, we will be using Anaconda, where we are going to be writing all our scripts when it comes to Python. And Python, it's a very great tool when it comes to machine learning, because it has a lot of libraries that makes your work easier, writing longer lines of code in shorter forms. Another thing we are going to be considering is the procedure we're going to be using. So as mentioned already, we are coming up, we have a proposed model, and the proposed model is the LSTM. So we want to give a graphical view of how the LSTM works. So figure 3 shows the LSTM diagram, or the model, and it has the input, it has the LSTM, it has the output, it has the classifier, and then it has the decision where it tells the user whether it's a normal attack or it's an abnormally, and whether it's going to alert the user or take no action. So with this model, this data set that we talked about earlier is going to be fed into this model. That's where we have the input, which is T1, T3, right onto T4. So after it takes in this input, it's going to, so the data that we're going to put in here is going to be the test, the training data. So in machine learning, before you train the model or to test the model, you have to split your data into two types, which is the training and the testing. So here, the first data set that we're going to be using is going to be our training data set. So we're going to give it that data set and allow it, which contains both normal and abnormal data of the IoT data of IoT devices, which is going to train it and get to know how it feels to have a normal network and how it feels to have a network where attacks are occurring on it. So after this process is being done and we get an output, the next thing to do is to test it with the other parts of the data. So in testing the model, that's when we are going to know whether the model actually performed very well. Was it able to classify it when an attack occurred? Was it able to do the needful? Was it able to do the tasks that is being asked to do? So it's just like, to understand this better, it's just like a kid trying to be in school, and then you tell the kid, oh, you have an exam in the next few days, and the kid decides to study for it. So after studying, the next thing is for the kid to write the exam. So it's the same way here. When you ask them to study, you give them the training data set. And when you want them to take the test to know whether they studied well, you give them the testing data set, right? And in the end, they give you the output. So if they studied well, they give you great output. If they studied wrongly, they give you wrong output. So that's the same way this model is going to do. So we continue where after the data set it's given to the model to test and train, the next possible thing is to evaluate the model. And to evaluate the model, I am considering 4 performance metrics, which includes accuracy, recall, precision, and F1 score. Looking at previous research in this field, most people base their conclusion of how their model worked based on only accuracy, which I think is totally wrong, because if you want to know how well the model performed, you don't have to base all your conclusion on how accuracy it is. It is accuracy, but then if you are trying to look in the area of prediction or classification, you should be considering precision as well. So I decided to include all these 4 matrices. So my model is going to be based on all these 4 matrices and not just one matrix. So as we talked earlier, we have accuracy, which is TP plus TN divided by TP plus TN plus FP plus FN. Recall is TP over TP plus FN, and precision is TP over TP plus FP. F1 is 2 multiplying precision times recall divided by precision plus recall. I know you are wondering, what is TP, TN, TP, TN, FP, and FN? TP simply stands for true positive, TN stands for true negative, FP stands for false positive, and FN stands for false negative. So all these are going to be considered in when we are evaluating our model. So to conclude in this research, first of all, we talked about why IoT devices has become very beneficial to us as humans right now, and how it is being used. But then, whilst it's being used and making our lives comfortable, it has security issues that keeps arising, and past research hasn't been able to solve it thoroughly. But according to research, they see implementing deep learning models as promising to help secure IoT devices. And so that is why I propose to use a deep learning algorithm to detect anomalies in IoT devices. We proposed a model which is called the LSTM model. We are going to feed it in with IoT intrusion dataset, which comes with a label of normal and anomaly. We could simply represent it as 0 for normal and 1 for anomaly. The performance of the model will be based on accuracy, recall, precision, and F1 score. And then with whatever we have, we are going to compare it to existing machine learning algorithms. Thank you very much, and I hope you enjoyed this presentation. Bye.